Twinkle, twinkle, little star? Or do they? Have you ever gazed up at the night sky and wondered about the tiny points of light that seem to flicker and dance above us? From a young age, we are captivated by the twinkling of stars in the night sky. It's a sight that has inspired countless poems, songs, and stories throughout human history. The stars seem to hold a magical quality, a sense of wonder that draws us in. They shimmer and dance, captivating our imaginations. The way they appear to twinkle can make the night sky feel alive, almost as if the stars are communicating with us in their own special language. But have you ever stopped to wonder why stars appear to twinkle while other celestial objects like planets shine with a steady light? This difference can be quite intriguing and leads us to question the nature of these distant lights. The truth is, stars don't actually twinkle. Their light is constant and unwavering, shining brightly across the vast expanse of space. So what causes this twinkling effect that we observe from Earth? Their distant light shines with a constant brilliance, but our view of them is distorted as it passes through Earth's atmosphere. The layers of air, with varying temperatures and densities, bend the light in different ways, creating the illusion of twinkling. This twinkling effect, known scientifically as astronomical scintillation, is a fascinating example of how our planet's atmosphere interacts with the light that reaches us from space. It's a reminder of the dynamic and ever-changing nature of our view of the cosmos. Next time you look up at the night sky, remember that the twinkling stars are a beautiful interplay between the vastness of space and the protective blanket of our atmosphere. It's a dance of light and air, a cosmic performance that has been enchanting humanity for millennia. Imagine light from a distant star traveling millions of miles through the vast emptiness of space. This journey is incredibly long, spanning light years, and the light remains mostly undisturbed as it travels through the vacuum of space. It's a straight path, a direct line from the star to our eyes. This light travels in straight lines undisturbed until it encounters the Earth's atmosphere. The atmosphere acts as a barrier, a final hurdle for the starlight to cross before reaching us. Earth's atmosphere is not uniform. It's made up of layers of air with varying temperatures and densities. These layers are constantly shifting and changing due to weather patterns, temperature fluctuations, and other atmospheric phenomena. As starlight passes through these layers, it gets bent and scattered in different directions. This bending, known as refraction, causes the light to change its path slightly. The varying densities of the atmospheric layers mean that the light is constantly being redirected. This bending and scattering of light cause the star's image to constantly shift and change in brightness, creating the twinkling effect we see from the ground. The star appears to dance in the sky, flickering and shimmering, all because of the complex interplay of light and the Earth's atmosphere. This phenomenon, known as stellar scintillation, is a beautiful reminder of the dynamic nature of our planet's atmosphere and the vast distances light travels to reach us. Think of Earth's atmosphere as a giant swimming pool. Imagine diving into this pool and looking up at the surface. The water above you is constantly moving, creating ripples and waves. When you look at the bottom of the pool from above, the objects at the bottom appear to shimmer and move around. This shimmering effect is due to the water's movement, which bends and distorts the light passing through it. This is because the water in the pool, like our atmosphere, is constantly moving and changing density. The varying density of the water causes the light to refract or bend in different directions. Similarly, the turbulent nature of our atmosphere, with its constantly shifting pockets of air, acts like a lens that bends and distorts starlight. These pockets of air vary in temperature and density, causing the light from stars to change direction as it travels through them. This distortion is more pronounced for stars because they are so far away and appear as tiny points of light. The light from these distant stars has to travel through vast distances of space, and then through our atmosphere, where it gets bent and scattered, making the stars appear to twinkle. This phenomenon, known as atmospheric turbulence, is why stars seem to dance in the night sky. It's a beautiful reminder of the dynamic nature of our atmosphere and the incredible journey that starlight takes to reach our eyes. Unlike stars, planets are much closer to Earth. While they also appear as points of light to the naked eye, their proximity means that they reflect a larger amount of light. This larger amount of light is less affected by atmospheric turbulence. Although the light from planets does get bent by the atmosphere, the variations are smaller and average out, resulting in a steady, non-twinkling appearance.